Well, hello Internet, and welcome to part 2 of my design patterns video tutorial. Today I'm going to finish up reviewing a whole bunch of basic OOP concepts by talking about polymorphism, abstract classes, abstract methods, and interfaces, which are basically just abstract classes with nothing but abstract methods. Don't worry, you'll get it. And also I get into a whole bunch of other different things about static methods and fields and a whole bunch of other things. So let's just dive into it. Now, like last time, I'm going to start off with a presentation and jump into the code. So I figure either way, you're going to completely get this concept. What is polymorphism? Polymorphism simply allows you to write methods that don't need to change if new subclasses are created. So for example, dog can add a new method right here, dig hole, without changing animal in any way. Also, if dog wants to override a method, it can do so, like it did here with eat, also without affecting animal in any way. On top of that, you're going to be able to refer to subclasses by their superclass type. So in this situation, you have doggy, which is really a dog, but we're going to think of it as an animal, and kitty, which is really a cat, but we're also going to look at it like it's an animal. In doing so, we're going to be able to create arrays that are going to have a bunch of animal objects. However, if you go and call kitty get sound, because of polymorphism, it's automatically going to execute the cat method instead of trying to execute the get sound method for animal. Don't worry, if you don't get it, you will get it. Just remember always that you can't access methods this way if they are only in the subclass. And that is where abstract classes and abstract methods and interfaces come in. So let's jump into the code. So here we are again in workwithanimals.java, and I'm going to create a dog and cat object with the superclass. So just like I showed you before, we're going to go animal, and I'm going to call this doggy is equal to new, and then I got to call the dog constructor. That's very important. And I'm also going to create kitty, just like you saw before. And in this situation, I'm going to call a cat constructor. So they are both animals, but they are also individually a dog and a cat object. And then we're just going to go system out, print line, and I can say doggy says, and then call doggy get sound, right like that. And then equally, I can do the same exact thing with our cat object, except I'm going to go kitty, and then call kitty. And then if we execute that, you're going to see that even though they are both animal objects, they automatically call the right method that is defined inside of their individual classes, doggy being the dog class and kitty being the cat class. All right, so let's demonstrate all the other things I was talking about. Let's also go animal, create an animal array here, and go animals is equal to new. And if you saw my Java tutorial, I did this a lot. So we're going to create ourselves an animal array, and we're going to say animals, the 0 index is going to be equal to doggy, and the 1 index is going to be equal to kitty. So we're just going to pass those objects inside of there. And equally now, we could cycle through these using a for each block, but either way, I'm going to do it this way. We can just go animal and call the individual index, and also do exactly the same thing for kitty and the 1 index. And if we execute it, the same exact thing is going to happen right underneath here. And there you can see, automatically calls the right method. You could also send animal objects for processing inside of a method, which is very useful. So let's create and call a method that doesn't even exist now, called speak animal, and then let's jump down here and create it. So we're going to go public static void speak animal, and I'm going to explain in a second here exactly why I'm using a static method, because that seems to be an ongoing question. And then I'm just going to go system out print line, and in this situation I'm going to go animal says rand animal get sound. So it's going to spit that out on the screen, and if I execute it, there you go. Animal says bark. So I can pass any object to this guy, and it's automatically going to call the right method. So there's a whole bunch of different ways of working with that sort of stuff. But like I said before, and this is very important, you can't reference methods or fields that aren't inside of animal. So with dog here, for example, see, I went and created or extended the dog class with dig hole. Now, if I come in here and I try to call dig hole, you would think it would work, but it doesn't, because the animal class only knows about methods that are in the animal class. See, this doesn't work. And if we zoom in here, you can see right here the method dig hole is undefined for the type animal. Now you could still use it, you're just going to have to come in and cast it to be a dog object. And there you go, now you see the error went away. And if we execute it, you can see dug a hole does work. Another thing that's important is let's scroll way up to the top here, and let's create an integer, and let's call it just a num, and just give it a value of 10. And then if we scroll back down inside of here, and remember, we're inside of main right here. Public static void main. It's a static method. And I'm going to demonstrate that you can't use non-static variables or methods in a static function. Print line and call just a number. And if we scroll inside of here, it's going to say cannot make a static reference to a non-static field, just a num. So you can't do that. So that's another thing that comes up all the time. So I'm just going to delete that. Just wanted to review it because it comes up. And then I'm going to scroll down here again. And I'm going to create a non-static method to demonstrate that you can't call a non-static method inside of a static method. These are just things you just have to remember. I'm going to call it say hello. And it's not really going to do much anything except print out the word hello. But it's not going to do that because whenever I call this, just like before, you're going to get an error message. Scroll in here. Cannot make a static reference to a non-static method. And that is also something that you must remember. And all the time, whenever I get questions like, why are you using static? Why are you not using static? There is your answer. And another thing to remember is you cannot call a private method even if you define it inside of a subclass. So let's jump over into dog.java. And I'm going to create a private method. Private void be private. There it is. And then this guy is just going to go in here and just print some stuff again in a private method. And then I'm going to show you, however, if you create a public method, and this is in the dog.java file, it can access information, however, in private methods. And that's a way around it. Probably not a good idea because what's the point? But either way, if you call this private method from inside of here, you are going to be able to access it. Let's jump back over into here again. Let's delete say hello because it doesn't work. And then we're first going to go Fido, which is a dog object. And we're going to try to call be private. And once again, you can see here, not going to be able to do it. The method be private from the type dog is not visible. That means you cannot access it. However, you can execute a private method using that public method that we created. Right like that, execute, and there you go, in a private method. So that's another thing that comes up all the time. Now what we're going to do is we're going to create a graph from an abstract class. But first, we're going to review exactly what I mean by abstract classes and abstract methods. Now, if you want the power of polymorphism without all the work, what you use is either an abstract class or an interface. And quite simply, to create an abstract class, all you would do is go abstract, public, class, and whatever you want your class to be called. And then to create an abstract method, likewise, you'd go and put abstract inside of here before you would put in the return type for your method. And then you end it with a semicolon. That's how you make an abstract method. There are no abstract fields or variables or instance variables, whatever you want to refer to them. And all methods don't have to be abstract inside of an abstract class. In an interface, as you're going to see in a minute, everything has to be an abstract method. So much so that you don't even have to put abstract in for an interface because it forces you to do so. And another thing to remember is inside of abstract classes, yes, indeed, you can have static methods. So we're going to jump into creature.java inside of here, creature.java. And we're going to create ourselves an abstract class. So I'm going to go abstract, public class. I'm going to call it creature. Another thing that's important to remember, I don't know if I said this or not, you cannot create objects from a class that is marked as abstract. That's very important. This can never be an object, just in case you want to block people from being able to turn a specific class into an object. That's how you do it. But of course, subclasses can still extend it. Otherwise, it would be completely worthless. Another thing to remember is protected fields are like private fields, except subclasses can inherit from them. So if I wanted to put inside of here, because remember there's no such thing as an abstract field. If I wanted to come in here and put in some fields, I can just go protected, int weight, protected string sound, and so forth and so on. And now every method that you're going to make inside of this guy that you mark as abstract must be overridden. However, like I said before, not all methods inside of an abstract class have to be abstract. So let's just come in here, abstract, void, name, string, new, name, and there you go. You just made yourself an abstract method. Pretty simple. And this is all about being able to use the power of polymorphism to create subclasses from all of these classes that you make. And that's what you do. And this is going to force your users of your class here to do things the way that you want to. Basically, we're just doing the same thing we did before, except we're not defining anything because that is our goal. We don't have a goal to do anything except provide the power of polymorphism so that all of this stuff can be extended. And then I could continue on and on and on. And there's code underneath the video that does continue on and on and on. So let's jump back over here, save this guide. And now that we have the abstract class all created here, or as much as we're going to create it, I'm going to use it over here to create the giraffe.java file. Again, this is still a class. So to create this, we're going to go public class giraffe extends creature. Put this inside of here, and we're going to get some error messages because we need to add all the unimplemented methods. So I'm just going to click on that, and it's going to automatically throw inside of there all the different methods that I want to use. So that's cool. And then what I'm going to do is create private string name, right like that. And then down through here, set name. Well, I'm going to get new name inside of there, and it automatically threw that in there. And I'm just going to go string is equal to new name. Well, this is name, of course. I'll save that. And then get name is just going to return name in this situation. I'm just going to do that real quick and then jump back over into work with animals. And we can see that we can make a giraffe object. And I'm going to call it giraffe is equal to new giraffe, like that. And then I can go giraffe set name. And let's just give him the name of Frank. And then system out print giraffe get name. Make a call to that. And if we execute it, you're going to see that Frank pops up. And there's Frank right there. So that's an abstract class. And that just leaves us to cover interfaces. Now an interface is a class with only abstract methods, like I said before. You can add as many interfaces to a class using implements as you want, which is absolutely fabulous. So now you're no longer limited to just extending one class. However, you're only going to be able to use public static and final fields if you choose to use them at all. And interfaces provide the ultimate in flexibility because your classes can come from completely different inheritance trees and still be able to use a common interface to communicate. And this is such an important concept that we're going to get into later on in future tutorials. So back to the code. All right, so we're going to create our interface inside of living.java, which is just a name I just picked up here. And just to cut to the chase, it's real simple. To create an interface, you're going to go public and then interface and whatever you want the interface to be called. And then you're going to define all of your methods in exactly the same way as you did with abstract classes, except there's one thing missing. There is no word abstract. The reason why is all of these methods inside of here are abstract by default. So that's it. I mean, that's all you do. So I didn't see any reason to retype all that. So there is an interface. And then if you would want to come in here and actually use this interface, we could come into monkey and you would just type in public class monkey implements and living. There is your interface right there. And then of course you're going to be able to click on it and all the methods that you're going to be forced to implement inside of this class are automatically going to populate it. So there is a whole bunch of stuff about object-oriented programming. Coming up, I'm going to cover a ton of design patterns and a ton on UML. Feel free to leave questions or comments below. Otherwise, till next time.